Okay, so now in this movie, we're going to demonstrate how to deal with liquid samples. Liquid samples are much easier to handle than the solid samples because the liquid samples we can just place between two already prepared salt plates. So the salt plates are also kept in the desiccator. Why would it make sense that we keep salt plates in a desiccator with drying agent at the bottom? So they don't absorb water because salt is very soluble in water and we could just end up with little puddles of salt water. So we tend to keep everything for IR inside desiccators so we can keep it nice and dry. For the salt plates, we have all varieties of shapes and sizes, and you can use any of them. They look in all different kinds of conditions. But even like these pretty ugly ones will still give us really good data because since they're just made of salt, even though they have like grooves and markings and etchings in them, they are not IR active and they still allow for IR light to pass through. And so they're just as easy to use. So you just want to choose two that are about the same size. That would be my suggestion. And so it can be two of the larger, two of the smaller. Maybe matching this one circle one with one of the smaller squares is not the best idea, but probably any of the others can be matched together. So to deal with the liquid sample, I just go ahead and lay out my two salt plates first and liquid sample, please. What kind of liquid is it?
Methyl benzoate.
Okay, so since you already have a pipette, I'm going to see if I can just like use my finger. All we need is a couple of drops. So I'll just do it this way to plate out a couple. We don't need very many. So I usually do keep a pipette in here, but it is, you never know who used it last, so it is really a great idea to come in with your own pipette. And then before it evaporates, you want to place the second plate on the top, and you just want to make sure that you had enough liquid so that it kind of spreads across the plate, at least through the middle portion. So now we can come over to the IR. Who would like to log in? Waiting. Usually this computer is a little bit faster. So once you log in, then what you can do is come to the desktop and you choose Easy Omnic. That's the software program that we use. I like to go ahead and expand it so I can easily see. So then the first thing that we're going to need to do is collect a background. And so let's go ahead and go to the instrument. So I can see, unfortunately, the last people left their sample in there. Oh wait, it was me. But this is a good highlight that it's important to go ahead and kind of clean up after yourself. But if anyone did leave a sample in there, what you do is you can go ahead, take it out. So the KBR pellets actually can just go into the trash because they are mostly salt, not anything else. And then can go back into the desiccator. The ball sits right there. And now we have our instrument with nothing in it, and this is the perfect condition for taking a blank. So we come over to the computer, select Collect Background, take the background, and as stated in the previous video, this is exactly what a background looks like. We don't want to add this to window 1, so we hit no. And now what we need to do is we need to put this assembly into place because it holds the plates. So we just slide this assembly down into the grooves. And now we set our salt plates just in the middle. Just trying to make sure that it seems like the liquid is kind of in that center part. And then we collect the sample. You can give it any kind of a name. Since you're dropping the data into a Word document, I'm not sure that giving it a name really is important, but you always could. It takes those 4 scans. So let's say that you didn't like this data because these peaks right here are really small and you think that there should be more significant peaks there. What you could do is add to window 1, no. come up here to collect, experiment setup, and then maybe we go out to like 32 scans and hit OK, and then collect sample. OK, it's ready. And now we just have to wait for 32 scans to go by. I usually find that if 32 scans isn't good enough for you, that you should just go ahead and maybe add more sample in between the two plates. Because if you get to 32 and the data is just not good enough, you should start over. It's not going to be that much better if you make it better. See how it's not changing all that much as we add those additional scans? Okay, so we can go add to window 1. Yes. Okay, so there's what your data looks like. Now, do you think that there should be an alcohol in here? You probably looked at the structure more recently than I did. Which one is this?
Methylbenzoate.
I don't think that there is with methyl benzoate. It's a little hard for me to remember. And so what we can do is now go ahead and label the data as I explained before. So we know that we're most interested in peak 1600 or above. So then there's this 1719, but we know that there's an aromatic. So it probably means this peak might be important. And there's our aromatic at 1597. And then we know that we should have at least one sp3 carbon dihydrogen, but we don't have a lot of sp3 carbon dihydrogens because that would be the methyl benzoate, and so that's why it's not very significant. We have some sp2, and it's hard to know whether we just don't have enough sample and if this is real or not. That's around 34. And so it's probably not necessarily a real peak, but maybe like a hint of an alcohol, but maybe that's like left behind from starting material. So it's probably not that real of a peak at all. And then as I explained before, I find it easiest to just go ahead and hit print screen and then go ahead and minimize this, bring up a Word document, and then go ahead and hit paste, and then you have your data right there. And then again, this makes a document that's easy to share between you and your lab partners and then easy to upload into Lab Archives. Okay, so let's go ahead and finish cleaning up from the liquid sample before we stop this video. So for cleaning the liquid sample, what you do is you take the salt plates, and then I always have a small bottle of toluene setting out. So what you do is you just go ahead and kind of slide the salt plates into the side, and then just swirl the salt plates around. They should, of course this time they're like staying stacked on top of one another. So if that happens, I have these large forceps because we need to get both of them a little bit more flat. There we go. So swirl. If you notice that there's just not much toluene like now, or it's very dirty, then you can just have your instructor get you more toluene. So once we swirl around in the toluene, then I always grab a couple of Kim wipes, lay them down, and then pull out the salt plates using the forceps. And then it's good to just go ahead and wipe them. And then whenever you're wiping plates like this, usually circular motions are better. They leave less grooves. So go ahead and just kind of wipe them down a little bit. So this helps get them the rest of the way clean. And they will still smell a little bit like toluene, but that's fine. The toluene is just going to evaporate. And so then you can drop them back into their box, close it up, put it back into the desiccator, and everything is nice and clean. Okay, so that's our video for how to deal with liquid samples.